Hi and welcome everybody here. Today we're going to talk about the smart grid distribution and which parameters we should consider while working on smart grids. So let's go one by one and see which are the important parameters to study about the smart grid. So the most important from the very beginning, if we go through this, is here is the power generation, amount of electrical energy generated by the system. Then the voltage, the potential difference between the 2 points and the frequency. Then the load demand. The load demand is the total electrical demand or the load that the grid is expected to supply. And also, it's important to consider because we are talking about a distribution network where we have energy from various sources, renewable fuel, hydro, and wind, and solar, and various other sources. So, energy storage is important. The capacity of the storage system, for example, batteries to store energy for later use. And then energy resource type, which type of energy resources we are using, categorization of energy sources into renewables and non-renewable resources. And the most important thing is the dispatch strategy. What's going to be our strategy to dispatch the electricity? So this is the method to allocate generation resources to meet demand while minimizing the costs. And at the transmission line capacity TLC, it's very important. So the maximum electrical power that can be transmitted through a transmission line. So the specifications of the transmission lines, losses, generation, everything. Then power factor and the generation cost. Power factor, the ratio of real power to apparent power. This is important, and we have to make sure that we optimize our smart grid to consider this important factor. At the generation end, the generation cost is very important, the cost associated with generating electricity. So if we have renewables and the fuel and hydro and other sources, so we have to make sure that if we are having the smart grid of like with having various sources of energy, so generation cost is very important factor. Then the generator's efficiency, the ratio of useful power output to the total energy input. So we produce the energy, we produce the electrical power, but this is important that we have to see the ratio of useful power output to the total energy input. Then renewable energy penetration is important, the percentage of total generation coming from renewable resources. So usually, is it like more than from the fuel generators or from the hydro? We have to see how much is the percentage of the renewable energy penetration. Then the non-renewable energy penetration, like the fuel generators or the hydros, the percentage of total generation coming from non-renewable resources. Just in case for a very smart or like very economical power system that it's not easy to do, like to have all the renewable energy sources, which is not I mean for the large cities or large metropolitan cities it's not possible. So the power losses, the amount of power lost in the system due to resistance, impedance, various other factors. Then the grid stability, the ability of the grid to maintain stable operation during disturbances. This is also important, and when we design the smart grid, we have to look into this thing as well. So the reactive power, of course, this is also very important. The power that oscillates between the source and the load, not performing useful work. I mean, it's kind of a loss. We that the reactive power we have that later on we can discuss this thing. So the reactive power is the power that oscillates between the source and load, not performing useful work. Now, the distribution energy resources, DERs, is small localized energy resources like solar panels or wind turbines. So there is like, if you see on the right hand side, there is the equations and formula for each one of those. So for the distribution energy resources, like there is no as such a formula that once we design, so we come up with various solutions. Then the smart meters, digital meters that provide real time data on energy usage. So they have to be real and correct meters to give us the, the real time data on energy usage. Then another important thing is the demand response. The strategy to manage electricity demand through incentives like once we will deal with the utility companies and the power generation and power transmission companies, if it's in the private sector or government sector, then we discuss this. So the demand response is important strategy to manage electricity demand through incentives. Then the environmental impact, that is the effect of power system on the environment, including emissions. Right, these days we talk about green environment, green emissions, and all that. So this is the very important to discuss here. Then the carbon emissions. When once we talk about the green environment, so we talk about carbon emissions, the amount of carbon dioxide released by power generation, which is a very important thing to discuss. And nowadays, different countries they are following the climate change principles and trying to reduce the carbon emissions. Then the fuel supply availability of fuel sources for non-renewable generation. So that is like the wind or solar, or if it's from the oceanic waves. So we have to make sure what is our source, how far is it, how reliable it is. So this is very important. Then the energy conversion efficiency, efficiency of converting one form of energy to electrical energy from what is our strategy to convert this for energy conversion efficiency. Capacity factor is another important thing. The ratio of actual output to the maximum possible output. So what is actual and what is possible, what we are looking for, and are we able to get the maximum power, the maximum output after using the smart grid and various energy resources. This is very important. Then the microgrid integration of small grids that can operate independently or with the main grid. So there are like two options: either they are incorporating with the main grid or they are working independently. Again, this is our strategy to see what we are looking for. Then the control and automation. This is very important for the engineers, for the designers, to make sure that the system is automated and is used for controlling grid operations. Because just creating an architecture and laying it as a smart grid system, it's very important, and it's like a lot of work to control and automate the system. Then cybersecurity nowadays, to protecting grid systems from digital threats and ensuring data privacy. So this is also very important. If we have designed uh, the best system and it's not secure, so there is no usage of it. Then the power quality. If I'm getting the power, but if the quality is not the required quality, so the consistency and quality of electrical supply voltages, sags, and harmonics. I mean, this is very important. Then the capacity reserve, extra generation capacity to meet unexpected demand. If there is a peak time or more users, consumers in an industrial or residential or commercial area, and we have to have some extra generation. Weather forecast is very important because the especially the renewable resources, wind and solar, they are dependent upon weather, the wind speed, the wind location, rains, snowfall, clouds, and all that. So prediction weather patterns for renewable energy availability is also very important. Now, the one most another important thing is the interconnection constraints, like the limitations on the ability to connect grids. Sometimes you can connect the grid, but there are certain limitations because of the specifications, loads, conditions, weather, and various other constraints. And we have to look into it. I mean, because all the smart grid systems in one area to another area, they may not be same. So there we have various interconnection constraints. Now, the marketing participation, it is very important. um, Participation of producers and consumers in energy markets, it's very important that the those who are producing electricity and those who are consuming it at the user end, how much they are willing to buy and how much they can sell, produce and sell. Then the generation mix is important. Combination of different energy resources used to generate power, as I said before, renewable and non-renewable energy resources. So how to mix them, which generator will be producing more or less, and what time, different time zones, different schedules, and availability of the energy resources. Then the load forecasting is also very important when we design our smart grid project. Predicting future electricity demand. It's not just you just did the work and you have an architecture and you have optimized the system, but we are not sure about the load forecast. So we have to see, like, for next year, next 6 months, in summer or in winter, what will be our load forecast? Will it be more or less? We have to produce more electricity, we have to supply more electricity, or we will have extra electricity, so we should know the load forecast. Then the power flow, that most of the time, being an engineer, we work on this distribution of power from generation to load centers. So if we have demand from various consumers in various areas, what is our mechanism of flowing the power, of, like, giving the power? So we have to consider that aspect as well. Um, when we are designing, we are working on it. Voltage regulation is very important. This is a technical thing. So adjusting voltage levels to ensure stable power delivery. So sometimes we step up and step down, or sometimes we regulate the voltage and we try to stabilize the voltage as required, when required, and where required. Then the grid resilience is also important. Grid's ability to recover from disturbance. If I have a system, it's working fine, but something happens and error stays there, it's going to create even more errors. So the grid is, we have to make sure if the grid is resilient enough. So the grid's ability to recover from disturbance. So that depends on the grid reliability models. Then the power system protection, we have to make sure we have devices to protect the system. This is the on the hardware side. The cybersecurity is in, like, the software side. So the protecting the system from false, like, overloads, right? So protection algorithms are used, for example, relay settings and all that. Then the dynamic stability, the ability of the grid to maintain stability under dynamic conditions. If not talking about a particular constant situation, if the things are changing day by day, time by time, usage wise or supply wise or distribution wise, so we have to make sure when the system is dynamic, it's stable as well. Then the asset management is also important. Management of physical assets in the grid, say like transformers or cables or devices, power electronic devices, regulators, relays, and all that, whatever infrastructure you have. So there is, like, no direct formula. It's a kind of a management tool that we have to make sure from the money point of view. Then the cost of emission reduction. So as we spoke about the green environment and gas emission, control the cost of reducing carbon emissions. If I have a system in which I am putting more money to reduce the carbon emissions, and it's but it is the system is not reliable in terms of it's not beneficial. We are spending more money on reducing carbons instead of making money or giving a benefit to the consumers. And then the voltage control devices, these VCDs, these are also very important that we have to deal with all these as well. So for the voltage control devices, devices to control voltage levels in the grid. So the control strategies, they depend upon device specifics, what specification you have, what is required, how to control, where to control, what to control. Power grid monitoring, this is again a continuous process, that continuous monitoring of grid parameters for proper operation. Sometimes if something is increased or is goes up, another goes down, or the one goes up, another also goes up, one goes down, another goes down, and that actually affecting other parameters, like because of fluctuation or change in one of the parameters, say there are 1, 2, 10, or 15 other parameters which are changing. So that depends on monitoring system configuration we have. Then the intermittency of renewables, IR, variability of renewable energy sources like wind and solar. If I have the source, I have to make sure, because usually we cannot have a constant wind or a constant solar, I mean the sunlight. So it depends upon the weather, day and night, and depends upon the wind speed, wind mapping, location, and all that. Now, the important thing that we usually discuss when we do the optimization is economic dispatch, which is very important, that determines the optimal generation mix to meet demand at minimal cost. If I am meeting my demand but my cost is higher than expected, so there is no usage of it. So there are certain equations for that, you can see on the column number third. Then the grid interconnections, connections between grids. Before we talked about connection between various devices. So now we are talking about connections between grids for power sharing and backup. So if I have one grid which is not giving me enough power, so I can get it from another grid. Or if one grid I have enough power, I can share it with a grid where supply is not enough. Now, the again managerial point of view from the management, consumers' behavior is important. The way consumer adjust electricity usage based on price. So the utility companies, they not always look into the technicality. They have to make sure what is the consumer behavior, how the consumer reacts for the adjustment of electricity usage based on price. And the last two things, grid communication infrastructure, communication network for real-time data exchange in the grid. If I have some data which is delayed, or usually it's not like ahead of time, or if it is delayed and I cannot control it, I can't do an automation because I'm getting the wrong information, or the communication network is not in real time. So it's useless. So the last thing is the power system stability margin, the ability to withstand disturbance before becoming unstable. It's like if you know a database, or if you have a table or a graph or some information about various kinds of disturbances, so you're ready for the power system stability. So you have a margin that if the error is up to this level, I can do this. If the error or any unforeseen condition happens and this is beyond the control, then you have to have a standby system. So these are some of the important uh, parameters that we have to see before designing the smart grid for transmission or distribution. So this is all for now. Thank you.